Hello guys, the last video we have seen what is cylinder, what are the different types of cylinder, okay, what is meant by thin cylinder, what is meant by thick cylinder, then what are the different stresses in thin cylinder and what are the different stresses in thin spherical vessel, okay. This much point that you have covered in the last video. Today we'll see the numerical which are based on stresses in thin cylinder and stresses in thin spherical vessel, okay. The statement they are mentioned as a pipe of 500 inner diameter made of steel, okay, and the material percentage they have mentioned carbon 15 percentage, magnesium 75 percentage, and the value of ultimate tensile strength they have mentioned is 440 newton per mm square, okay, is to be used for carrying the fluid under 65 bar pressure. The efficiency of the longitudinal and circumferential joint are 75% and 70% respectively. If the factor of safety is 4, then determine the thickness of the pipe. It means from that numerical, the ultimate aim is to find out the thickness of the pipe. Okay, the first thing always while solving the numerical is you have to write down the given data first. Okay, so read the sentence again. In the first line they have mentioned inner diameter. As I said, we are going to denote the inner diameter by using di. It is how much? 500 mm. Next, in the next line they have mentioned the ultimate tensile strength is how much? 440 newton per mm square. So this value also write down here somewhere. Ultimate tensile strength is 440 newton per mm square. After that, in the third line they have mentioned the pressure is how much? 65 bar. Okay, just remember here they have mentioned the unit of pressure is bar, but we are following what? SI system, that is international standard units. So in that case, what is meant by pressure generally? Tell me. Pressure is nothing but what? Force per unit area. The unit of force is Newton and area is in mm square. This is the SI unit. So we have to convert this bar into Newton per mm square. Basically, there is a unit conversion. Okay, you should know the unit conversion because from the first year you are learning the units. Okay, so that is most important. If you don't convert this unit into proper unit, okay, in that case your answer will be the wrong. Okay, so the basic conversion is what? 1 bar is equal to how much? 10 raised to 5 pascal. Okay, and 1 pascal is equal to 1 newton per meter square. It means this 65 bar is nothing but what? 65 into 10 raised to 5 pascal, or it is also called as 65 into 10 raised to 5 newton per meter square. Okay, again you have to convert this value into what? Newton per mm square. So you have to divide this value by 1000 square. So you will get the final pressure is 6.5 newton per mm square. After that, in the numerical they have mentioned two efficiency. One is 75% and another is what? 70%. So write down this value, and the factor of safety they have mentioned is 4. As I said in the last video, the first thing that you have to find out is what? Allowable tensile stress, because in order to find out the thickness we required what? Allowable tensile stress. So allowable tensile stress is nothing but ultimate tensile strength divided by factor of safety. Maybe you have seen this formula from the last years in both the semester in DME1 and DME2. So ultimate tensile strength they have mentioned is 440 and the factor of safety they have mentioned is 4. So here you are getting allowable tensile stress is equal to 110 Newton per mm square. After that, finally we have to find out the thickness of the pipe. Okay, now there is a big question. Okay, the thickness in the numerical they have not mentioned whether it is a thin cylinder, whether it is a thick cylinder, they have not mentioned. So in that case we have to initially assume this is the thin cylinder. We have to follow the trial and error method. So initially we are assuming this is a thin cylinder. So for the thin cylinder the formula is already we have written in the last video. T is equal to pi into divided by 2 times sigma all into ni. Pi they have mentioned, D also they have mentioned, allowable stress is 110, and here NL. Remember in that formula we are going to take only NL. NL is nothing but longitudinal efficiency and this value is 0.75. So this is 0.7. Once you put all this value, you are getting the value of T is how much? 19.7 or which is equal to 20 mm. But the big question is what? Here we have considered this is what? A thin cylinder. Okay. For a thin cylinder, you should remember there is a one ratio, that is di by t. It should be greater than 20. It means the value of di is how much? 500. T just you have calculated is how much? 20. This ratio should be greater than 20. If this condition is satisfied, it means the cylinder that we have assumed is what? Correct. So here we are getting the value 25, which is greater than 20. So it means what? The initial assumption that the pipe is thin cylinder is correct. Okay, this is the numerical which is based on what? Thin cylinder. Okay, next numerical which is based on thin spherical vessel. Okay, because in the first line they have mentioned this is what? Spherical steel vessel. The sentence is what? A spherical steel vessel of storage capacity, this value is 0.0335 meter cube, is to be subjected to an internal pressure of 135 bar. Again here pressure is mentioned in bar. The joint efficiency they are mentioned 75%. If the allowable tensile stress for the vessel is 120 Newton per mm square, you have to determine the dimension of the vessel. Okay. Here in the second line they have mentioned the capacity. Okay, as we have seen in the last video, the capacity is nothing but what? Volume. And unit of volume in SI system what? Mm cube. So you have to convert this first thing meter cube into mm cube. So you have to multiply with what? 10 raised to 9. Next is pressure. Pressure they have mentioned is how much? 135 bar. Again convert 1 bar is equal to how much? 10 raised to 5 Pascal. So 135 into 10 raised to 5 Pascal is nothing but Newton per meter square. So it is 13.5 Newton per mm square. After that, I have mentioned the joint efficiency. For thin spherical vessel, joint efficiency is denoted by letter NC. Okay. And the last is they have mentioned allowable tensile stress, that is sigma all. In the last numerical, they have not mentioned this value directly. So we have to use the formula sigma all is equal to S of ut divided by the factor of safety. But here they have given the directly final value. So there is no need to use that formula. Okay. Here you have to find out the dimension of the vessel. Dimension is nothing but we have to find out the thickness of spherical vessel. What is the formula to find out the thickness of spherical vessel? This is T is nothing but Pi di divided by 4 times sigma all into NC. We know the value of Pi, we know the value of sigma all, we know the value of NC. Unknown is what? Di. So first thing is you have to find out the Di. There is one more formula to find out this Di is what? Inner diameter of vessel, that is V is equal to, it is pi by 6. Okay, V is equal to pi by 6 Di cube. Okay, V you know, so the only unknown term is Di. So in this term put the value of V. Okay, do simplification. Okay, take the cube root and all those things, and here you are getting Di is equal to how much? 400 mm. After that you are going to find out the thickness of vessel. Okay, the formula is T is equal to Pi into Di divided by 4 times sigma all into NC. Put all this value just you have calculated here. Here you are getting T is equal to how much? 15 mm. Again you have to follow the same procedure. Here by using trial and error method, the first thing that you have to consider is what? It is a thin vessel. So for the thin vessel, the condition is what? Di by T should be greater than 20. Di here you have calculated is 400. T is how much? 15. So 400 divided by 15 is how much? 26.66. Again this value should be greater than what? 20. If it is greater than 20, then it is what? Thin vessel. This 26.66 is greater than 20, so it means it is a thin vessel. So hence the initial assumption is what? Correct. Okay, these are the two numericals which we have seen on the thin cylinder and thin spherical vessel. Okay, in the next video we are going to start with thick cylinder. What is meant by thick cylinder? What are the example of thick cylinder? What are the different stresses induced in the thick cylinder? What is the difference between thin and thick cylinder? That we are going to cover in the next video. Okay, thank you so much guys. Stay safe, stay at home. Okay, thank you so much.